When I push this jar, the water resists and it piles up at the back. That is inertia, as you all might have heard. Nothing surprising there. Now I add one extra thing. A table tennis ball which is tethered to the bottom of the jar. Same jar, same water. Now if I push it similarly to the video that you just saw, what do you think will happen to the ball? Where does it go? As usual, before we explain anything, we need to know what is at play here. What are the variables that affect our system? The density of the ball, the density of water, the jar in which it's placed, the force that I apply to the jar to push it, maybe even the friction between the floor and the jar, the temperature, pressure of water surrounding, everything counts. And from these, let's frame a few questions that we can actually test. Will the tether have any effect? Will the water push the ball forward or pull it back? Does inertia or gravity or anything like these play a role here? These are all valid questions. We'll see how it goes. Before we proceed, these are the three predictions that popped up. Option A, it moves backward. The inertia of the ball keeps it behind as the jar accelerates. Option B, it stays in place. Maybe the water just holds it there. Option C, it moves forward because the jar is moving forward. It should move forward. And now it's time to look at the demonstration. Whoa, that's interesting. It moved in the direction of the push. That means the ball moved forward. And what about the second object? Even that moved forward, right? We'll come back to that in a bit. We know what happens now. The ball moves forward with the push. Now the big question is not what, but rather why. Why did it even move forward? Run this demo in your class before showing any cards. Don't say anything and let the students just watch. And then ask, what did you expect? Almost every student will say backward. That gap between what they expected and what they saw, that is a real lesson. So don't close it too fast. This brings us to the central part of the Inquiry Saga, the hypothesis. Hypothesis 1, the tether story. When the jar accelerates, the string gets taut and the tether naturally pulls the ball in the direction the jar moves. This sounds possible. It's mechanical but plausible. Hypothesis 2, Newton's word. When the jar accelerates, the water pushes everything. So the ball which is lighter experiences more acceleration according to F equals ma, force equals mass times acceleration. Sounds about right, isn't it? Hypothesis 3, the pressure imbalance. When the jar accelerates, the water piles up at the back, creating higher pressure, leaving low pressure area towards the front. This pushes the ball towards the front because of the pressure gradient. At this point, all three hypotheses explain the same observation as to why the ball has moved forward. The students cannot tell them apart just by looking at the ball. That's the whole point. So the next experiment is about not confirming the result, but to find the explanation that actually holds. Let's look at one experiment which will separate them. Now replace the table tennis ball with a dense metal bearing suspended from the top of the jar submerged in water. Same jar, same water, same push. Now remember the second clip from the beginning? The second object that appeared to move forward? That was the bearing footage. It was just flipped. Now this is the original video. The bearing actually moves backward. I'm not kidding. It's the same water, same jar, same push. The movement is just in the opposite direction. Now what does this experiment has to do with our hypothesis? Let's look at it one by one. Hypothesis 1 said the tether pulls the ball forward. In this case, the metal bearing is also tethered, but it moved backward. So hypothesis 1 is not quite true. Hypothesis 2 said that the less mass moves more forward. Here the bearing has more mass, but it didn't just move forward less, it actually moved backward. So hypothesis 2 might not actually be the reason. Hypothesis 3 talked about pressure imbalance, where a difference in pressure sorts out objects with different density. This sounds about right. Less dense goes forward, more dense goes backward. The bearing confirms it. So we have hypothesis 1, which is wrong. So we use the red worded card. And then we have hypothesis 2, which is also wrong. So the red worded card again. Hypothesis 3, which the bearing confirmed, is partially right because we still haven't discovered why the density determines the direction. Now that's what deep dives for. When the jar accelerates, the water resists and piles up at the back, creating low pressure in the front as we've just discussed. Now this pressure difference acts on every object that's submerged in water. Now two objects, same pressure acting on both. The table tennis ball is hollow and has almost no mass compared to the metal bearing. The density is lower than water. The force from the water pressure easily dominates over the inertia of the ball, and hence the pressure pushes the ball forward. On the other hand, the metal bearing has more density, and this helps inertia dominate the water pressure, and hence the bearing resists the motion while the jar accelerates. Now this is buoyancy, not vertical but horizontal. You've seen this before, not just in the same direction. Remember the paper and the book experiment that we tried? Let me just show it to you. Here I have a book and a paper. If I place the paper on top of the book and let go, the book clears the air below the paper, which eliminates buoyancy, and the paper falls straight through. Here, the fluid is water instead of air, and the direction is horizontal, but the physics is identical. Here's the teacher's secret. In any accelerating fluid, whether it's air or water, objects sort according to their densities. Less dense objects move to the low pressure area, and the more dense objects move to the high pressure area. So vertical buoyancy, horizontal buoyancy, buoyancy in any direction, it's the same physics, just rotated. When I first saw this demo, I certainly thought the ball would go backward, like most students in your class did. I knew Newton's first law. I had taught it to students, but here, I was wrong. That's not embarrassing, that's just another reason to keep learning. That is what inspired me to make this video. These are the Inquiry Saga cards for this topic, pre-filled and ready to print. The link is in the description. There's one new card in this set, the prediction card. This is the card that creates surprise even before the observation lands. So if you haven't checked out my other video on buoyancy which I mentioned earlier, please click on this video next. See you there.